Hello students, in this video we will discuss about a concentration term which is called parts per notations. So it is to be noted that the parts per notation is the pseudo notations which are used to describe or which are used to express the unitless quantities like mass fraction or mole fraction. So this is parts per notation, maybe pph, which is called parts per 100, or parts per 1000, and parts per million, and parts per billion, and parts per trillion. So how we can explain these concentration terms? So parts per 100 means 1 part per 100 gram, and the like this ppt means 1 part per 1000 gram. Parts per million means 1 part per 10 to the power 6, and parts per billion means 1 part per 10 to the power 9. In the same way, part per trillion means 1 part per 10 to the power 12. So these are the concentration terms which is used when the relative concentration of solute present in solvent is very less. So the solvent content is very high as compared to the solute. So we can say that these parts per notation measures the concentration when the concentration is very less, or these measures the dilutions. So the most important parts per notations are ppm, which is parts per million, and parts per billion, which is used to measure the relative abundance of dissolved minerals or pollutant in water basically. So parts per million, how we can define the parts per million? Simply we can say that ppm is milligram per liter, and in the same way ppb is microgram per liter. So whenever it is required to calculate the ppm, just focus on the milligram per liter, and when it is required to calculate ppb, you will focus on the microgram per liter. Suppose this is a bottle which is labeled as x ppm. So how we can decode this? We can decode this: x gram of solute, x gram of solute present in 10 to the power 6 gram of water or solvent. Yeah, we can say that x gram of solute present in, the density of water is 1 gram per ml, so we can write this 10 to the power 6 ml of water. Yeah, we can say that x by m moles of solute present in 10 to the power 6 ml of water. So this is the way by which we can record if a bottle is labeled by x ppm. Since 10 to the power 6 ml water contains x by m moles of solute, we should say this is m1, which is the molar mass of solute. This is the molar mass of solute. So we can find the molarity of the solution, because since 10 to the power 6 ml contains 10 to the power 6 ml contains x by m1 moles. So because molarity is defined per liter of solution, solute per liter of solutions, so we can say that in 10 to the power 3 ml contains, we can calculate for 10 to the power 3 ml or 1 liter. It should be equal to x upon m1 into 10 to the power 6 into 10 to the power 3. It will make x by m into x by m1 into 10 to the power minus 3. So obviously this amount will represent the capital M, which is the molarity of the solution. So it is very important relation that we get that molarity can be easily converted into parts per million, as molarity is defined as moles of solute per liter of solution. So moles per liter can be converted simply into gram per liter by multiplying it by molar mass of solute, which is m1. This will give gram per liter, and gram per liter can be easily converted by milligram per liter. It can be easily converted by milligram per liter by multiplying by this 10 to the power 3, and the milligram per liter as we said that it is called the ppm. So simple, we can say that we can convert the molarity into ppm by multiplying mole per liter into m1 into 10 to the power 3. This will give milligram per liter, which will represent the ppm. So how we can explain the problem based on the ppm or parts per million? So let's take an example to explain this. Suppose it is given that a bottle is labeled as 40 milligram per liter of calcium per liter. So this is the bottle of mineral water, and this is labeled as 40 milligram per liter of calcium. This is labeled as this, and now it is required to calculate, find number 1 ppm, number 2 concentration of Ca+2 ions by mass, or we can say that percentage by mass of Ca+2 ions, and number 3 is concentration of Ca+2 ions in mole per dm3. So these three parameters are required to calculate when a bottle of mineral water is labeled as 40 milligram per liter of calcium, calcium per liter. So how we can start this? It is required to calculate ppm. We know that the ppm is, we are solving first part. So ppm is milligram per liter, and it is given that 40 milligram per liter. So this quantity will represent directly ppm. So the first answer is 40. Now it is required to calculate percentage by mass of Ca+2 ion. So very obvious, percentage by mass of Ca+2, we can calculate that, you know that mass of Ca+2 divided by mass of solution into 100. This will be the expression. So mass of Ca+2 will be, it is 40 milligram, which can be written as 40 gram, divided by, you know that mass of solution will be 1000 into 1, because the density of water is 1 gram per ml. So the weight of solution will be 1000, and this will be multiplied by 10 to the power 2. So definitely on solving this, you will get 4 into 10 to the power minus 3%. In the third part, it is required to calculate the concentration, which is the molarity of Ca+2 ion. Means that ppm is required to convert into mole per dm cube or mole per liter, because 1 liter is equals to 1 dm cube. So 40 milligram per liter of Ca plus 2 is to be converted into concentration. So 40 into 10 to the power minus 3 will be the moles of Ca plus 2, divided by 40 will be the moles of Ca plus 2, and the volume is 1 liter because it is milligram per liter. So this will give 10 to the power minus 3 mole per dm cube, which is the simple conversion of ppm into mole per dm cube, or concentration, which is molarity. We can take one more example, that if 40 gram of MgO dissolved in 40 gram of MgO is dissolved in 200 ml of water, 200 ml of water, then find parts per million. So in this case, the volume of water is given and the density of water is considered as 1 gram per ml. So simply we can calculate ppm is equals to weight of solute upon weight of solution. You know that in this case the weight of water is considered because the weight of solution is approximately equal to the weight of solvent, because the solvent content is very high. So weight of solvent we can consider here into 10 to the power 6. So weight of solute is given as 40 gram and weight of solution will be 200 into 1, and we will multiply by this 10 to the power 6. So what you will get? You will get as 1 by 5 into 10 to the power 6 ppm. So this is the parts per notation which is generally used to express the hardness of water. It is very useful to express the relative abundance of dissolved minerals and pollutants in water. In the next video, we will discuss about the hardness of water while by using the parts per million concentration term. Thank you very much.